In the previous video, we used LangChain to call LLM. We asked AI questions and AI answered them. In this video, we will use RAG, a powerful AI framework, to allow LLM to read my local files and data. I will ask AI questions again, but this time, AI will answer questions based on my local files and data, and in the answer, mark which file and which part of the content is specifically referenced. Let's take a look at this LangChain, which we built at the end of the previous video. Okay, I'll find the place to fill in the question, and now I'll write a new question. Here, I asked a question about The Little Prince. This is a novel written by French writer Antoine de Saint-Exupéry. This question requires AI to know the plot of The Little Prince in order to give an appropriate answer. Okay, I'll run it now. Let's see how the LangChain we built in the previous video will answer this question. Very good. AI knows this question and points out that it is related to The Little Prince written by Antoine de Saint-Exupéry. But then something went wrong. AI described the relationship between sheep and flowers like this. They imply two different worldviews. People who have read The Little Prince can quickly see the problem. AI overinterpreted it here. In addition, the following explanation about the fox explaining to the little prince why flowers have thorns was made up by AI. Obviously, AI confused multiple plots and characters in The Little Prince. This is the hallucination problem mentioned in the previous video. This is because when LLM was training, it may have read the text of The Little Prince, but did not remember every detail of the book well. If we can submit the text of The Little Prince to AI as context when asking questions, we can avoid hallucination. And RAG, which I will introduce today, is a technology that allows the context text of the question to be attached. This is the RAG process built with LangChain, which is roughly like this. I have an electronic PDF file of The Little Prince in my notebook. This RAG process can read my local file and submit it to AI as context. I will run it now to see if the answer given by AI is different from the previous one. It's finished. Here are the questions I asked, and below are the answers given by AI. The quality of this answer is much higher than before. If you have read the original text of The Little Prince, you can be sure that AI's answer here is completely in accordance with the original plot, without imagining any extra things. In particular, the source of the reference is marked in the answer of AI. Based on this, we can see which texts AI actually referenced below. The specific page and the original content are all marked. In this video and the next video, I will show how to build a RAG with LangChain step by step. If you can finish watching it, you can also build such an AI process on your device, read your local PDF file, and let AI generate an answer with a citation mark and reference to the original text. Of course, this process requires Python to write some code. If you are not familiar with Python programming, you can also download the code I wrote directly without having to write the code yourself. I will upload all the LangChain processes built in this video to GitHub for everyone to download. Okay, let's restore the LangChain process to the beginning of this video. Next, let's look at the prompt template. This template only contains the question asked by the user, which is not enough. We also need to attach contextual information related to the question. Here, let's modify the text of this prompt template again. Here I tell the AI that the fragment in the context comes from a book. Finally, tell the AI that if the context information is irrelevant to the user's question, just answer, "I don't know." This can prevent the AI from imagining some non-existent information. Okay, here, we fill in the word context and wrap it in curly braces. When the AI executes, this part will be replaced with the real context information. Finally, the user's question is written here. Here, I suddenly want to change a word, let's call it input, to distinguish it from the previous video. Okay, in the end, I adjusted the entire prompt template. The main thing is to add a context. Then, the user's question was changed to input. Next, if you still remember the content of the previous video, you should have guessed it. I want to build a dictionary object with two keys called context and input. This will match the part in the prompt. So here I have to write Python code again. Let's change the title here and roughly explain what this code is going to do. It means to create a params with code. Okay, it's done. Let's take a look. I read a parameter from inputs called retriever, which is a concept in RAG, and I'll briefly explain it later. Anyway, my code requires the upstream of this block to pass me an object called retriever. Therefore, I changed the input field to retriever and then changed its type to variable. Because this retriever is a Python object, I don't want to serialize it and then deserialize it during the transmission process. The variable type tells OOMOL to pass Python objects directly and prohibit serialization. So, OOMOL reminded me that this retriever must be connected, otherwise it won't work. But I don't care, it will be connected by a block upstream, and the upstream will pass a retriever to me and then pass it here. Then I wrote it here in the context and used this symbol to connect it to a function called formatDocs. This symbol is a symbol specified by LangChain. I also wrote this formatDocs function. Let's see what I did. Here I used a regular expression, which is actually to merge the spaces and carriage returns in the document into one line. In this way, when AI reads it, it knows that this line should be treated as a whole. Then all the process documents are merged into a large string, separated by a blank line in the middle. In this way, after reading the code, you can imagine what the text in this context will look like in the end. In addition, here in input, I wrote a runnable pass-through. This is a special object of LangChain. It is used to replace the text directly entered by the user. Here, it refers to the question asked by the user. Then, these two fields will be wrapped as a dictionary object and output to the downstream block as prompt params. Therefore, we have to write it out here in the output. So, what is its type? Just like in the previous video, set it to any? No, because the input field of this dictionary is a runnable pass-through object. I must ensure that OOMOL will not be serialized when passing it, so the type here must be variable. Connect them together so that this object can be passed intact to the downstream block. So far, our code corresponds to the prompt template written earlier. This context corresponds to this context, and this input corresponds to this input. This is the params I defined with code. I also wrote a formatDocs function to format the documents read by the upstream retriever. Okay, this block is finished. Let's prepare its upstream block. I wrote a retriever here, so where does this retriever object come from? Let's drag a chroma retriever block over and connect them together so that we can provide a retriever object for the downstream. For LangChain, retriever can query and return a set of documents based on the user's question, as the context of the question, and be attached to AI for reference. You can think of it as Google or any search engine. The user's question will be written in the search bar in advance, and then Google will search, and all the results on the previous page will be excerpted and submitted to AI as context text. In this way, Google search is also a kind of retriever. So what is chroma retriever here? It refers to the retriever implemented with chroma. Chroma is a vector database. You may have heard of the concept of vector database, and you also know that it is always closely combined with LLM. Here, you can simply regard the vector database as a full-text retrieval database. The user stores all the text in the vector database in advance. For example, here, I will store all the content from the first page to the last page of The Little Prince. When the user asks a question, the user's question will be directly used to search in the vector database, and the top 5 closest documents will be used as the result and written into the context text. Here, the vector database uses a special technology that can achieve a similar effect to fuzzy matching. After the introduction, chroma retriever, let's take a look at its fields. The most important field is documents. Here, the upstream will pass the text of the entire book, The Little Prince, as a document array and store it in the vector database here. Of course, when searching, a part of these documents will be selected and handed over to the downstream formatDocs function for processing. So, in the final analysis, the document data processed by formatDocs comes from here. Then, let's look at the embeddings field. This field requires that the upstream provide an embeddings object to convert the text string into a vector. This is the source of the vector database's ability to perform fuzzy queries. Specifically, if the distance between the vectorized sentence strings in the vector space is very close, it means that the semantics of the sentences are very close. In short, we need to provide this embeddings object to chroma block. Then, the database path field is used to indicate in which folder the vector database is stored. I set it up. Look here, I store the vector database in this folder. This field, search K, means that only the top 5 contents of the documents searched by the user's question are written into the context. I think it can be more, let's search 10 documents. Of course, this is adjusted according to the needs. There is no requirement to search 5 or 10. The last field is called reset database at beginning. This is not fully displayed. I drag it a little bigger. Forget it, that's it. If this field is checked, then every time the documents field receives data, the folder where the vector database is stored will be cleared at the beginning. In the development state, this is a very convenient function because the data generated last time will be cleared every time. Okay, that's all. Let's prepare another block. First, let's prepare an embeddings object. There are 2 types of embeddings, one called OpenAI embeddings and the other called local embeddings. What's the difference between the two? For OpenAI embeddings, it requires you to upload the text you need to embed to the OpenAI server, which will then convert it into tokens and then transfer it back to the local machine. In this example, this requires us to upload the entire text of the book, The Little Prince. In actual scenarios, we may even have to upload many massive PDF files. To be honest, I don't really like this solution. I prefer to embed these texts directly into tokens locally. Therefore, I deleted the OpenAI embeddings block and used the local embeddings block. It supports downloading the embeddings model locally and then using local computing power, such as my own graphics card, to embed the text into tokens. We paste this multi-QA mini LM field in the ID field. When we start for the first time, LangChain will download the model from Hugging Face through this ID. This model can convert a sentence into a token, which is exactly what I want. The second field, query template, requires us to tell it how to get the query text. I wrap an input with curly braces here. Why is it input? Because the text entered by the user is defined as input. Therefore, the user's input text will be used as query text here to query relevant content from the book. Okay, everything is filled in. Let's connect here. The embeddings are configured. Then we prepare the block upstream of the documents field. I will drag another code block and name it load documents. Next, I will write code to load the text content of The Little Prince. So, the first step is to define a PDF_file field and define its type as file. In this way, it will become a file selector. Okay, we found it. It is the PDF file of The Little Prince. Let's select it. Next, we read this PDF file from the code. First, delete these comments. In this way, this variable gets the PDF file path we just set. Then, we need to read this PDF file from the path, which requires a library called PDF Plumber. But you can see that an error is reported here, because we haven't installed it yet. Now open the Packages panel and search for PDF Plumber here. That's it, this is the library we need, and then install it. You can see that there is no error here, indicating that PDF Plumber has been successfully installed. Then continue to write code to read the PDF file corresponding to this address. Here, we use the extract text simple method to read the text from the page. Then I will print out these contents first. and then I will run it directly to ensure that these codes can correctly read the PDF file content. Click Run and switch here to Styo. Okay, let's take a look. No problem, the PDF content is indeed successfully read. Okay, just confirm that we have successfully read the text. Change a name here to represent the text content of each page. Next, I will store these contents as document objects. I will prepare an array. This document object does not exist yet, so I will import it. So we will create it below and insert it into the docs array. That's it. All the texts in the whole book will be stored as document objects in this array called docs. After that, we need to split the document into smaller pieces. LangChain provides us with tools to split document, which we can use directly. Define chunk size and chunk overlap here. This text splitter can split the previously defined document. Why do we need to split the document here? For vector databases, the amount of text in a page of PDF is too much. Let's take a look and see that the amount of text on each page is still very large. If it can be cut smaller, the search and matching results will be better. Okay, so with this line of code, the original document read from PDF can be split into smaller granularities and finally returned here. Then connect it here. However, pay attention to the type here, which should be variable. Why change the type? Because we use document here, which is a Python object, and I hope it will be passed directly to the downstream block instead of being serialized. Okay, so far, the entire RAG LangChain has been built. Finally, here we need to change it. Let's make it output a string instead of a dictionary. Why don't we use a dictionary here? Let's look here. Look, I set a runnable passthrough object for the input field here before. The position of this object will be directly replaced by the user output by LangChain. If we still output a dictionary, then the prompt params here will become a dictionary containing a dictionary, which is obviously not the result we want. By the way, the type here should also be changed to a string. I will change it again. Everything is ready. Let's run it and see how our adjustment works this time. After running, this is the answer returned by LLM. Let's put them side by side as in the previous video. This is the question I asked. What is the story behind the millions-year war between sheep and flowers? How does the little prince understand why flowers have thorns? This is the answer given by LLM. The story behind the millions-year war between sheep and flowers is that the flowers have been growing thorns for millions of years to protect themselves from being eaten by the sheep. The little prince understands why flowers have thorns by questioning the purpose of the thorns and realizing that flowers grow thorns just for spite, believing that their thorns are terrible weapons. The little prince sees the conflict between the sheep and the flowers as important and questions the significance of the warfare between them. From this answer, it seems that LLM has a deeper understanding of the text of the book, The Little Prince. What caused LLM's answer to change in this way? Why not take a look at the logs and see what changes have taken place in the question text that we finally submitted to the LLM server? Let's take a look at the logs of invoke chain block. I'm now switching to Styo, which can exclude other irrelevant logs and look more comfortable. From here, this is the question text that LLM actually receives. You see, this is what we wrote in the prompt template before. But starting from this line, These are all excerpts from the book, The Little Prince. If you look further, you will find that the book excerpts related to our questions are directly excerpted. Finally, the user's real question is written here. Therefore, the answer given by LLM is the answer to the user's question after referring to this entire paragraph of content. Finally, this paragraph of text is output. Instead of saying that, as before, the text is generated only based on the text of the user's question. So, where do the excerpts of the book we just saw come from? In fact, they are read from the codes I wrote before, that is, from the PDF file I specified. But the content of the whole book is complicated in the past, and some mechanism is needed to filter it. Therefore, here comes the chroma retriever block, which will vectorize the content of the whole book and store it in the vector database. This vector database is saved in this folder. Then, the downstream will use the user's question as text to query in the chroma retriever block. The chroma retriever block will vectorize the problem and find the 9 closest documents to pass downstream. Then it will be received by the code I wrote earlier. I did 2 things here. First, I removed all the carriage returns in each document, using a simple regular expression here, so that each record becomes a single line of text. Second, I concatenated all the documents into a large string separated by a blank line. This large string is the value of the context field of the prompt perms dictionary. That is, as we can see, the entire part of the text. This is what this code does. Okay, this is all that happens when LangChain runs once. But I have to say that every time it runs, LangChain will vectorize the entire content of the entire book and store it in the vector database. Notice that this field is checked. This means that before each vectorized book text is written, the database will be cleared. This is a good debug option because it ensures that the entire text is read from the PDF file and the database is reset every time. However, if you no longer need to debug, you will find that it is not necessary. Reading the entire book and vectorizing it only needs to happen during the first execution. Therefore, after the first successful execution, we delete the connection here. This will force the downstream block to query the document fragment from the vector database in this folder each time, instead of executing load documents every time. In this way, the waiting time for each execution will be shorter. So far, our LangChain flow has been built. However, there is still a shortcoming. Although its answer is made with reference to the original book fragment, we hope that it can give the specific citation source in the answer. I plan to show you this part in the next video. That's all for today's video. Thank you for watching.